Good morning, students. Today we will do properties of definite integrals. Some properties of definite integral. Now, properties which we have to learn and how to apply this we will study in this video. Now, here's the first property which we apply, that is, if you are integrating a function from a to b to the function fx dx, if you want to change the variable of this function, then there is no change in the answer. We have done in previous video, as the function substituted and changed into the new variable, you will get the same answer. Second property, integration from a to b to the function fx can be integrated interchanging the limit. Interchanging means upper becomes lower and lower becomes upper. There is a change in sign take place, minus that becomes b and it is a, f of x dx. If a and b are equal, then integration to the function fx dx will be equal to 0. Third property, integration from a to b can be calculated by using the property splitting or getting the another point in between a and b. From a to b interval, you are taking c any point which is lying between a and b, that is a c point, and c to b, f of x dx. Now, fourth property, that is integration from a to b to the function can be done as integration from a to b f of a plus b minus x dx. When you replace this x by this number a plus b minus x, then the integration values are same. Now, property number 5. Property number 5 is a minus x property is the name of this. It's a very important property. 0 to a fx dx, that can be written as from 0 to a f of a minus x dx. You can replace x by a minus x. Now, property number 6. If 0 to 2a limit is given to the function fx dx, that can be written as 0 to a fx plus limit from 0 to a f of 2a minus x with respect to x. Now, seventh property, 0 to 2a can also be calculated by using this one, that is, if I have to write down, if f of 2a minus x equal to f of x, then you can integrate only twice of 0 to a function fx dx, then both solution will be same. If f of 2a minus x is equal to minus of fx, we are getting answer 0. You can write directly the integration of that function will be equal to 0. Now, property number 8. In this property, you have to check whether the function is even or odd. On the basis of this, you can write integration from minus a to the function fx dx is equal to twice of 0 to a fx dx only if the function is, if f is even. Now, what is the meaning of even function? It means when you are putting minus x at the place of x, you are getting function fx It is equal to 0 if function is odd. Odd means when you are putting f of minus x, getting the value minus of fx, then function is odd function. You can say here, for example, I can say suppose function is sine x, sine square x. So f of minus x will be equal to what? Sine of minus x, and this is square. This comes out equal to minus sine x whole square, and you are getting sine square x. It means you are getting f of x back. When you're putting minus x, you are getting f of x same as. It means this is a function, even function. Suppose, for example, fx is equal to cube sine of cube x, and when you're calculating minus x on the at the place of x, you are getting minus sine x whole cube, or you can say minus sine cube x. It means you are getting what? Minus of fx. This means what? Function is odd function. And this is the even function, this is the odd function. This is a way to check whether function is even or function is odd. Now let's apply properties on the given questions. We'll do few questions related to properties. Here is example number 30 on page number 343. Example number 30 on page number 343. I will just give you an idea how to solve such type of questions. Mod of x cube minus x. In such type of questions, you have to just pick the function. Function is x cube minus x. Because here mod sign is there, you have to check where it is positive or negative. You have to get the intervals where this becomes positive or negative, this function. Now, first of all, simplify it, factorize, get the factors of the statement. What you are getting? X is equal to 0. X square minus 1 equal to 0 gives you what? Plus minus 1. Or you're getting 0, 1 and minus 1. Take the number line. 0 is here, minus 1 is here, this is 1. And 2 is given in the interval, that is 2. Now here are 3 intervals, you are getting minus 1 to 0, 0 to 1 and 1 to 2. Now our target is to get what is the answer in the interval from minus 1 to 1. Take minus 0.5 and put it in a x cube minus x. What you are getting, whether positive or negative, you have to check it. Now take 0.5 in the interval from 0 to 1. And again put the 0.5 in the interval in the equation x cube minus x, and check what type of answer you are getting, positive or negative. For the interval 1 to 2, put 1.5 in the equation. As you are solving the equation, you are getting, in the first you are getting positive, the second you are getting negative, and you are getting positive. It means this integration can be written as minus 1 to 0 from x cube minus x dx, and plus 0 to 1, minus sign will be there, x cube minus x, like this you have to write down. In the interval from 1 to 2, function comes out again positive, like this. Now this minus sign can be solved, it can be written as here minus 1 to 0 integration x cube minus x dx, minus 0 to 1 x cube minus x. Or you can write it like this. Suppose we can write it like this. Let's write like this. Suppose this is minus sign is multiplied inside, then this same as positive, but x comes out and x cube, like this. You can write 1 to 2 x cube minus x dx. Now you can integrate these parts. This is I1, this is I2, this is I3. Simplify these three, I1, I2, I3. Integrate and put the limit. What you are getting, you will get answers like this. I will write down. You are getting like this. Integration is equal to x to the power 4 upon 4 minus x square by 2 minus 1 to 0 plus x square by 2 minus x to the power 4 upon 4 0 to 1 x to the power 4 upon 4 minus x square by 2 from 1 to 2. Now get the values and you will get upper limit minus lower limit. Upper minus lower. Put the limits and you are getting answer 11 by 4. Now do this, simplify your on here. It's okay. Now come to the example number 31. In example number 31, integration from minus pi by 4 to pi by 4 to the function sine square x. As I have told you, this is the even function. I have told in the on the first slide, it is an even function. If it is an even function, you can write like this: twice of 0 to pi by 4 to the sine square x dx. Now how to integrate this sine square x? You can write it like this: twice of 0 to pi by 4 sine square x can be written as 1 minus cos 2x upon 2 dx. From here it comes, you can use the formula cos 2x is equal to 1 minus 2 sine square x. Now integrate it. This becomes 1, 2 takes outside. This is 1 minus cos 2x. This comes out x minus 1 by 2 sine 2x and 0 to the 1 pi by 4. Put the limit pi by 4 minus half sine pi. Sine pi is 0, only answer will be, this is 0. So answer is equal to, sine pi. This is not pi. This is pi by 2. And this is minus half into sine pi by 2 is 1. So it is pi by 4 minus half. This is the answer. Now come to the question, example number 32. Example number 32. Question is, integrate from 0 to pi to the function x sine x upon 1 plus cos square x dx. Question become, now we have to apply a minus x property on this. But you are getting I is equal to 0 to pi, x becomes pi minus x. Put x is equal to pi minus x in the question. And now you are getting integration from 0 to pi. This is pi minus x. As it is, sine 180 minus x is sine x upon 1 plus cos square x dx. Now solve the power and split the denominator. It comes out 0 to pi sine x upon 1 plus cos square x minus x sine x upon 1 plus cos square x. Now you can see second part it as I. This is I and this is I. You can take this statement to the left hand side. You are getting twice of I will be equal to 0 to pi sine x upon 1 plus cos square x dx. Now we have to solve it after substitution. What you are getting? Question is I is equal to, take the 2 to the right hand side, pi by 2 from 0 to pi sine x upon 1 plus cos square x. Now let cos x is equal to t. Then what is derivative? Minus sine x dx dt, or you can say minus sine x dx is equal to dt. It means sine x dx is equal to minus dt. And from here, if x is 0, this implies t will be equal to 1 because cos 0 is 1. If x is pi, then t will be equal to minus 1. Now question becomes I is equal to pi by 2 and take minus sign outside. Now it becomes 0 becomes 1 and it becomes minus 1 dt upon 1 plus t square. Now integrate it, minus pi by 2. Integration is tangent inverse t. And this is 1 to minus 1. Now we can not integrate it like this. Let's do, because it is, here is a need to change the limit. 1 to minus 1. A to minus a can be converted into 0 to a. It means minus 2 times of pi by 2. It becomes 0 to 1. Applying property from a to minus a. Or you can apply the property, change the sign. First minus a to a, change the sign positive, and then 0 to a. Apply property, here apply property. Okay, it becomes now dt upon 1 plus t to the power 2. Now it becomes integration, that becomes pi, that tangent inverse t, 0 to 1. Here you have to apply properties. Try to understand. This is pi tangent inverse 1 minus tangent inverse 0, 0 becomes 0 part pi of pi by 4. It comes out pi square upon 4. This is the answer. Here this is the important part, because 1 to minus 1 you can't integrate because the function is not continuous in the interval minus 1 to 1. So change is required. Change the limit from 0 to 1. Then you can do the question. Now example number 33, that is very easy example. The function is the odd function. You can write directly the value will be equal to 0. I have told you how to check the odd function and even function. You can check it. It is an odd function. Now come to the example number 34. Integration of the function from 0 to pi by 2. That is sine to the power 4x upon sine to the power 4x plus cos to the power 4x dx. Now apply a minus x property on it. 0 to pi by 2 sine to the power 4 pi by 2 minus x sine to the power 4 pi by 2 minus x plus cos to the power 4 pi by 2 minus x. Now we have to simplify. 0 to pi by 2, and this becomes 90 minus theta. That comes out cos to the power 4x. This is cos to the power 4x plus sine to the power 4x. Which property we are applying? Sine 90 minus theta is equal to cos theta, and cos 90 minus theta is sine theta. Now this is the equation number first. Take this is equation number second. Add first and second. What you are getting? I plus I, 2i. And integration of 0 to pi by 2 sine to the power 4x plus sine to the power 4x plus cos to the power 4x plus cos to the power 4x cos to the power 4x plus sine to the power 4x. When you are adding these two, because limit is same, you can add by taking the LCM. Numerator and denominator becomes same. What you are getting? 2i equal to integration of sine to the power 4x plus cos to the power 4x upon same. You can write 1 because they are cancelled to each other. Limit is from 0 to pi by 2. Now integrate from 0 to pi by 2. 0 to pi by 2. 1 dx, and this is x 0 to pi by 2, it becomes pi by 2. So I will be equal to pi by 4. This is the answer. Now apply the property on example number 35. Which property? 0 to a to b property. A to b to the function fx is equal to f limit f of a plus b minus x dx. That property you have to apply. Question becomes easy. Do it your own. Now we'll do example number 36. Very good example. Example number 36. Let's do example number 36 on page number 346. Integration of the function from 0 to pi by 2, and function is log sin x with respect to x. Now here in this question, 3 or 4 properties are applied to do or to simplify the question. We have to just practice for this question, then you can do question. Otherwise it's difficult to do because 3 or 4 properties are in a same question. We have to apply. Now this question, now first of all we have to apply a minus x property. A minus x means replace x by pi by 2 minus x. Let's do sine pi by 2 minus x. Now equation becomes 0 to pi by 2 log of sine 90 minus x is cos x dx. Now in this question, it is first, no sorry, it is second, it is first, adding first and second. What you are getting, I plus I, it is 2i is equal to 0 to pi by 2 log sine x. Same power is there, you can write like this. Now here you have to apply the log property. Log m plus log n is equal to log mn. Okay, the question become like this: 0 to 2i, 0 to pi by 2 log sin x into cos x with respect to x. Now here you have to add and subtract log 2 because you want to formula sin 2x formula in this question. Adding log 2 and subtracting log 2. Next step will be 2i is equal to 0 to pi by 2 log, here we have written sin x cos x, but I said adding log 2 and subtracting log 2 in the question. When you are compiling these two, you are getting 0 to pi by 2 log 2 sin x cos x log m plus n and minus log 2 as it is with respect to x. 2i is equal to 0 to pi by 2. This is log sin 2x minus log 2 dx. Now here you have to integrate the second part. You can write like this: 0 to pi by 2 sin log sin 2x minus integration 0 to pi by 2 log 2 with respect to x. The first part, take it is as it is 2i is equal to integration of 0 to pi by 2 log sin 2x, and if you integrate it taking log 2 outside, integration of 1 from 0 to pi by 2, that becomes x, and it is pi by 2 log 2 integration of this one. Okay. Now one integration is left which you have to do by substitution. Now 2i is equal to, let's put first part, that is let 2x is equal to t. 2 dx will be equal to dt, and for the limit, if x is 0, then this implies t will be equal to 0. If x is pi by 2, then this implies t will be equal to pi. So question become 1 by 2, 0 to pi log sine t dt minus pi by 2 log 2. Now here in this question applies here 0 to 2a property. 0 to 2a means 1 upon 2 twice of 0 to half. If it is 2a, then half of this is pi by 2. 0 to pi by 2 log of sine t dt minus pi by 2 log t. Now this becomes 2i is equal to integration 0 to pi by 2 log of sine t can be written as log x. When variables are changed, no change in the answer. So this is what? This is I. 2i is equal to I minus log pi by 2 log 2. What this implies? Take this I to the left hand side. I is equal to minus pi by 2 log of 2, and this is the answer of the question. You can do examples of exercise 7.11 and try this exercise 7.11. This is a good exercise, and one question is always there in the CBSE exam. Do these questions. We will discuss few important questions of exercise 7.11 in next video. Till then, do these examples and try exercise 7.11. Thank you. Have a nice day.